So we've had our Mixergy IHP integrated heat pump cylinder for a few months now, and I'm really pleased with how it's been running. The energy use is super low, and we've always got hot water, and it's been brilliant. It's so easy to use. So what I wanted to show today was one of the main benefits of having a smart cylinder like the Mixergy IHP is the app that you can use to control it, and the web portal, and all of the controls and data that you can get just by having an online cylinder. So let me show you the app, and I'll walk you through it bit by bit. I've got it on my phone here, and I'll show that on the screen. And I'm going to just go through each of the settings and the various tabs that you can use to control things. So let's start with the main page here, and you can see that you get a nice sort of friendly display showing how much hot water you've currently got in your cylinder. Kat and I have had our showers this morning, so we've used about roughly half the cylinder to do that. You can scroll up and down. There's not really a lot to scroll here, but probably the most important thing that you can see right in the middle there is the boost button. So if we did want to boost the cylinder, boost the amount of hot water that we've got, we just tap that boost button in the middle. We can set however much we want here, and hit set, and that will then kick in the heat pump, and it will start heating the water. Now I'm not going to do that now because I don't want to boost it right now, because the most efficient way of heating a heat pump cylinder is once a day, and basically heating it all the way up to full, which does also mean that if you're using the boost mode, it's slightly less efficient than if you were heating the cylinder from cold. So you get a coefficient of performance of about 3.4, something in that ballpark if you're heating from cold. But if you're using boost mode, it's more like a coefficient of performance of about 2. So we operate it just heating once a day, and I'll show you how I do that in a minute. But the boost function is super useful if we've got guests around, for example, and we want to just top up the cylinder, and there at that point it actually heats from the top and pushes that hot water section further down, so that you've always got hot water right at the top rather than heating from the bottom up. That's a very useful functionality, but obviously it's slightly less efficient than if we were just heating from cold once a day. That's what we tend to do most of the time, because there's more than enough hot water for Kat and I for any given day. Aside from that, the other thing that you should probably be aware of is this sort of menu button at the top right hand corner there. So if I tap that, and here you'll find kind of the main tank settings. So if I click on tank settings, you'll see that the first thing at the top there is the target temperature. So we can just tap that, and I can pick anywhere from 45 to 55. I've tried it at 55, and it comes out super, super hot. Actually, it's hotter. It comes out hotter than 55, in fact. I'll do a video about that maybe at some point. But I measured the temperature of the water coming out the taps at closer to 60. I think maybe there's some small calibration issues there. But setting it for 52 feels about right for this time of year. Back in the summer, I was setting it to about 49, 48, something like that, and that was fine. But setting it to 52 just gives us slightly warmer water for when we need it for showers and for washing up in the evening and that. So I just change that as and when I feel like we need a change in temperature. If I feel like the water's not quite hot enough for washing up, I'll just notch it up a degree and see how that feels. So I did that the other day. We were on 51 for a while, and I've just notched it up to 52, and we'll probably leave it around about that for the rest of the winter. So that's dead easy to change. There's this option to maintain target temperature. I don't tend to use that just because heating the cylinder once a day is sufficient for us, but if we did need to reheat the cylinder, then I could turn that on, and if it dropped below a certain temperature, then it would reheat the cylinder. But I don't want it to do that, so I've left that turned off. And of course, there's these little links here where it says temperature help, and if I tap on that, it will tell you some information to help you understand what that setting does. And there you go. It's just it explains what I've just said there. Grid assistance, enable grid assistance. I've left that off again. I don't really want it to be doing anything outside of the times that I want it to be charging, filling up. So I've just left that off, but you can read all about that in the settings there if you want to. Automatic schedule control, I've also left that off because, again, I just want to heat once a day because it's the most efficient way of doing it. If I click on the help there, you can see that there's a lot of information here. I'm not going to go read all of this. But I'll scroll that slowly. So if you really want to read all that, you can. But it just means that it will take control of your cylinder and do the scheduling for you. But I don't really want it to do that for the time being. I may or may not try that out in the future. I'm undecided about whether to do that. But I've just left that off because setting up the schedule, heating once a day is fine for us. The cleansing, this is the Legionella cycle, and you can see here you can choose the temperature. I've set it to 55. It doesn't go any hotter than that, but it doesn't need to. 55 is more than enough to kill Legionella, plenty in fact. And you can just tell it when to start, so you can just set the time of day and what days you want it to do that. It will do it by default every 2 weeks. If it's not ever hit 55, it will just boost to 55 on any one of those days at its when it deems it necessary. But I just leave it. It can pick it any day it likes. In reality, it doesn't tend to do that cleansing very often because we heat to 52, as I show in this target temperature here. It actually gets to about 55 at the bottom of the cylinder anyway, so it doesn't tend to need to do the cleansing really very often. Time zone there, very straightforward. Frost protection. Again, I'll tap the help there, and you can see it just means that it will make sure that the water doesn't drop below 5 degrees. That in reality never happens. Our cylinder is in the garage, and the garage never really gets below about 12 degrees when it gets really cold in the winter. So the water going in, it's never too cold. I think about 10 degrees is about the coldest the cylinder will get over the winter. Medical research, you donate your tank's brain power to medical research. I'll tap that help button there. I've not tried this. I don't know how much extra energy that would consume. That's something I need to ask Mixergy about actually, because I'm unclear about whether that would increase the energy consumption of the Mixergy controller. But yeah, I've not clicked that, but that's available if you want to. The one thing that you may not be aware of is the Mixergy IHP actually has a built-in solar diverter, which you can use if you're able to run an Ethernet cable from your router to, actually it's not the router, there's a separate box in fact that they install. If you can run that from your meter box, which is where they install this the CT clamp that measures the excess going back to the grid. If you can run an Ethernet cable from that to your Mixergy cylinder, the IHP, then it will be able to use solar diverts to run the heat pump to heat your hot water in situations where that's appropriate. I've not done that. I've got a cable ready to go, and I've run it through the wall, but the problem is I had to snip the end off, and I've not yet reconnected the Ethernet cable socket onto the plug rather onto that cable. So I need to do that at some point. In reality, at the moment, with the way that tariffs are, that's not really super necessary to do, because obviously if you have, for example, Octopus outgoing at 15 pence a kilowatt hour, if your overnight import rate is less than that, well, there's no point doing solar divert. You may as well heat overnight, which is in fact what we do. So I'm not in a great hurry to implement that, but it's there if you're on, for example, the feed-in tariff, and you want to use solar divert, then that's built right into the IHP, so that's super useful. And then there's the option at the bottom there to show the power, the clamp power. So that's the CT clamp that measures the export going back to the grid. You can show that on the graph, and I'll show you that in a second. So yeah, we're done with the settings. So let's go to the schedule tab there at the bottom. This is very easy to set up. So I've just got this set currently to heat the cylinder at midnight, and you can edit it here, change the time if I want to, and choose the day. So I've just set it to Monday, and the reason I've done that is because if I go all the way back here, you can see that the rest of these are just set as same as Monday, which is brilliant. So just set it once and away you go. You can just duplicate that all the way down. Very easy to do. And if I wanted to, I could add another schedule, but I don't really want to do that, so I'm not going to bother. And the other thing that is worth pointing out on this particular tab is this little button at the top with what looks like a little aeroplane taking off. And if I tap that, you can see you can set holiday mode. Now this was really useful when we went on holiday in October, and you can basically just set your departure date and when you want to come home. And it means that you don't need to turn off the cylinder. It will automatically disable the heat pump while you're away, and on the day you return, it will set it back on so that the normal schedule resumes, and that's really useful. So I actually set it to a day before we came back, so that the cylinder had time to heat up before we got home, and we had hot water for when we got home. That was really, really useful. That's useful there. And there's a setting here: ignore timer control cable, e.g. Hive. We don't have one of those, so I don't ever bother with that. But that's something you can use if you need to. Next tab along here is the graphs tab. Now this is my favorite, obviously. So let's click that. So this shows today's chart. Now you can see there's three little tabs at the top there. We've got hot water level, power, and PV power. Now hot water level obviously is how much hot water you've got in your cylinder. Now I have some minor issues with the way this chart is displayed. I think it's a little bit misleading. So you can see that this section here where it's shaded in pink, this is when the cylinder was heating up, and it heated up from about 30 odd percent all the way up to 100, and that's fine. But then you can see it's decaying very, very quickly. Now that decay I think is a little bit too fast. So it's not actually the level of the hot water in the cylinder. So the way the cylinder works is you've got the cylinder, and the hot water, the hot bit of the water sort of stays at the top. This is just through natural, because obviously hot water is less dense than cold water, so the hot water literally floats on top of the cold water. And in between that is a layer called the thermocline. And in a Mixergy cylinder, it's very, very thin, which means that you've got quite a good, strong separation between the cold bit and the hot bit. It's all one cylinder, but it's just separated by this natural thermocline in the water level. And the heat doesn't tend to translate down to the cold section very quickly at all. It's just one of those strange physics things that the water does, which means that block of hot water at the top stays pretty warm, and and the only way it loses heat really is through the walls of the cylinder. It loses a small amount into the bottom, but most of the heat dissipates through the walls of the cylinder. The cylinder is very well insulated, of course, and that dissipation happens very slowly. But that actual block of warm water stays more. If you don't use any, it will stay pretty much that volume of hot water. It just cools very slowly. Now, I think this display here is a little bit misleading because it suggests that you're actually losing hot water. In reality, I think what this is it's a heuristic. So it's an estimate of how much usable hot water you've got based on not only the volume of hot water at the top of the cylinder, but also the temperature. So as the temperature very slowly declines, this metric is also declining. But in reality, you've still got the same volume of hot water. It's just not quite as hot as it was maybe at the start here. So at this point, it was 52, 53 degrees or whatever, and it's very slowly cooling. But let me just show you very quickly what that looks like on the web app, because that actually shows a little bit more information. So I'll be right back with you in a second. Right, so this is that same chart, but shown on the web portal, and I've actually picked a different day. I've picked the 7th of November because I can show you the full day's worth of data. And you can see once again, this is the period where we heated up the cylinder. It went from, the measure there is 1.9% full. And then as it gets, so the heat pump is heating the cylinder, but obviously it's heating from the bottom, and that water then sort of hot warm water then rises to the top, and then at some point the cylinder decides, okay, the temperature of the top is starting to increase, and therefore the volume or the usable hot water suddenly zooms up to 100%. But you can see some other lines on here which you don't get on the mobile app, which I would like to see on the mobile app actually. So on the mobile app you can see this state of charge of the hot water, and you can see the power. I'll show you that in a second. But you also get these other two lines. You've got the top temperature, and you've got the bottom temperature. So you can see what happens when you start to heat the cylinder is the bottom temperature starts zooming up, whereas the hot temperature stays pretty stable. But as the water rises from the bottom up to the top, you can see that at this point the water at the top starts to increase in temperature. And it's at that point that the state of charge of the cylinder zooms up to 100%. So it's only when the top of the cylinder, the temperature at the top of the cylinder increases, that the charge percentage increases. But you can see then after that, the temperature in the top of the cylinder starts to decline, but very, very slowly. So at this point it was at 50 degrees. But you can see that the charge percentage drops now down here to about 90%, but the top of the cylinder is still at about 49 degrees. So it's not really dropped by much. It's dropped by, well, about 1 degree in this time. And over the course of a full day, by the time we get to the evening, this is when we did the washing up, for example, it's 43 degrees, but that's still very usable temperature. But by this point, the state of charge of the cylinder has dropped down to 9%. Now, I don't believe that that's true at all, because this initial drop here, which is where we have our showers, drops down to about 50%. That I more or less believe. But there's still 50% of the cylinder is hot water. It's just slightly cooler hot water than it was at the start of the day. So this is still absolutely usable hot water at 43 degrees. But it claims that the state of charge has dropped to about 9%. But there's still half a cylinder's worth of hot water, and we could use all of that half a cylinder's worth of hot water. It's a minor quibble. I don't really mind. In reality, I think most people would just get on with their lives and not worry about this stuff. But I'm a bit of a pedant when it comes to data, so I'm not sure about this heuristic. I think it could do with a little bit of tweaking. At the very least, I would like to see these temperature lines in the mobile app. So tell you what, let's go back to the mobile app and we'll carry on the tour. Right, so we're back on the mobile app, and I can continue with showing you the charts on here. Now, if I click on this power tab in the middle of this chart, you can see this is exactly what I showed on the web portal. You can see that the power is displayed here, and you can just flip between hot water and power. If we had the solar divert on, I could click on this PV power, and it would show how much export we were generating at the time. But obviously, as I mentioned, I haven't got that hooked up yet. But that's the charts that you can see on the mobile app. If you want to, you can pick a date and go back to any time you like. So tell you what, let's show the same data as I showed on the web portal. Click on that, and you can see that's the full day's worth of data. And again, I can just flip to the power. And if I wanted to see how much energy we used on this particular day, I could click on Insights, which is the final tab along the bottom there. And I can either click on what we used today. So at the top there, you can see we've used 0.95 kilowatt hours at a rate of 8 pence. So that's based on the current tariff rate. So our current tariff rate is overnight is 8.5 pence, because we're on Octopus Go. And you can enter that information. I'll show you that in a second. And that will then calculate how much that's cost you in terms of total energy use. Now, you can see now at the bottom there is the set tariff button. If I click on that, you can set the peak price and then any off-peak periods. And you can see that I've just set that up as midnight to half past 5, 8.5 pence. Now the peak rate it depends, because we've got obviously a solar and battery system. So if we were to heat the hot water during the day, and I have done that, it may or may not be drawing from the solar or the battery, which means that actually it's not really running at 25 pence per kilowatt hour. But let's not worry about that. That's a minor thing. If I wanted to see historical data, I could click on energy usage over time. That's the next one down. And this shows me by default the last 7 days. And if I scroll up, you can see the actual values there. So we're using between 1.6 and 1.8 kilowatt hours a day, typically for the hot water that we use. And you can scroll back through if you wanted to see past data. One thing I would like to see would be to be able to export this data from the web portal. You can't do that currently. You can export a lot of information, but it's not in a sort of convenient per day format. So that's something they may or may not add later. We'll see. If I click on per month at the top there, that then gives you a summary for each month in the current year. We got our cylinder installed in July, so we've got data going back to July. We're halfway through November now, so you can see that that's a little bit lower than the other months. October we were away for a couple of weeks, so we used less hot water obviously during that the time we were not at home. But you can see typically we're using between 30 and 40 kilowatt hours a month, which is fantastic. We were using about 150 a month prior to getting the cylinder installed. So it's definitely reduced our energy consumption considerably, which is the whole point of getting the cylinder in the first place. So there you go. There's also this hot water usage over time. Again, these metrics I don't really believe. So we have a 180 litre cylinder. We use about half of it. I'm absolutely certain we don't use more than about half of it. But this is showing me that we're using about a whole cylinder every day. I don't believe that that's true. So again, I think this is partly due to that slightly misleading metric. But I don't really look at this anyway. The most important thing from my perspective is the energy use rather than the hot water use. So I'm not too bothered by that. The final little option here is the weekly summary. If I click on that, it just tells you a little metric about how you compare to everybody else. Again, I never really look at this. Just gives you that warm fuzzy feeling if you're feeling competitive and you want to prove that you're the most energy efficient person in the country. Fine, if that's the sort of thing that you enjoy. But yeah, there you go. That's it really. That's all of the main controls. Very simple app to use, very quick and easy to learn how to navigate around this. But if you were curious, don't yet have a Mixergy cylinder, the app itself is the same for all cylinders. The IHP obviously is a little bit different because it uses a heat pump to do the heating, and that may change the way you want to run your heat pump, as I mentioned before. So we heat once a day because it's the most efficient. If you had a standard Mixergy cylinder, then you might want to engage the sort of machine learning algorithm that learns your usage pattern, and then it will top up your cylinder as and when required using the built-in immersion. Oh, that's one thing I should mention. The Mixergy IHP does have an immersion heater, but it doesn't operate by default, and actually you don't have any way of controlling it directly. If the heat pump fails, the way Mixergy explained it to me is that the immersion heater would become available, and it would be the way that it would heat as a backup. But it only becomes available if the heat pump itself fails. So generally speaking, you won't ever use the immersion heater. It doesn't even use the immersion heater during the Legionella cycle because the heat pump can get sufficiently hot that it can kill Legionella anyway. So it never uses the immersion heater, which means that even the Legionella cycle is still quite efficient and doesn't use any more than you would otherwise hope to use to do that cleansing cycle. So there you go. That's everything I wanted to show you today about the Mixergy app, in particular how it relates to the IHP. I hope you found that useful. If you're thinking of getting the IHP, I couldn't recommend it highly enough. Just having access to the data and the ability to control the temperature really simply and easily, it just makes life so much easier. So it's well worth getting just for that alone, really. Even above and beyond the energy savings that you get by having a heat pump doing your hot water. So yeah, thanks very much for watching. Hope you found that useful, and I'll see you in the next one.